Hey guys, welcome back. We're going to deep dive into IGMP version 2 and kind of discuss what IGMP version 2 did for advancing IGMP version 1. We're not going to talk about how multicast is distributed through the network just yet. We're just going to talk about how hosts declare what groups they're interested in and how routers maintain that information. So to get started, let's go ahead and go over to the whiteboard. And this is the setup that we have right now in GNS. We have two routers, R3 and R4, and both of these routers on this segment are responsible for maintaining that group listing. Now don't get confused, IGMP is not going to maintain a listing of every single host that is requesting a group. It's just going to maintain a general idea of a particular listing of groups that these hosts are interested in. As a basic level of introduction, we're going to talk about joins, IGMP joins. If a host is interested in a group address, and we are going to use the group address of 224.7.7.7, host 1 is going to declare on this segment that it wants to receive 224.7.7.7. So it's going to send an IGMP packet out with a destination address of 224.7.7.7, and within the IGMP packet, it's going to specify the group address of 224.7.7.7. When these routers see this IGMP membership report, and it's actually called a membership report. It's not called a join, although people will refer to it as a join. The correct term is membership report. When these routers receive this membership report, it will install it into their IGMP database of what groups are active on this segment and capable of forwarding multicast onto this segment for that group address. So the question comes in, now what happens when this host basically powers itself? What if this machine goes down? What if this host goes down? Well, it would be undesirable for multicast to continue to be forwarded onto this broadcast segment to the destination address of 224.7.7.7. So we get into this idea of one of these routers maintaining a kind of a pulse onto the broadcast segment, saying, you know, who's still interested in multicast groups? And you know what? Tell me which ones you're still interested in. And it's the idea of a querier. That's what's called a querier. Let me go ahead and erase everything here. And it's the querier's job to be that pulse. It's going to pulse a message out onto this broadcast segment saying who is still interested in multicast and tell me which group addresses you still want to listen to. And it's not going to be both of these routers. It's only going to be one of these routers. And one of these routers will become the querier. And how that's elected, there is an election process. The querier will be the router with the lowest interface IP address. And how that's elected is both of these routers, when their interfaces are up, they're going to send an IGMP general query out the interface with its source IP address of the interface IP address. So let's walk through the process. R3 sends out a general query onto this broadcast segment. R4 sees this general query and says, you know what, the source address has a lower IP address than what I have, so you know what, I'm not capable of being the querier. And the same thing happens when R4 sends that general query out onto this broadcast segment to 224.0.0.1 with a source IP address of 100.4. R3 sees this general query and says, you know what, I have a lower IP address, so I win. I'm going to be the querier. I am the router responsible for maintaining what groups are active on this broadcast segment. So let's get more into what the query is and what the querier does. So the query, we know, we talked about it. The query is what's called a general query. Now a general query specifies all group addresses. It's basically a message out to this entire segment saying, tell me what multicast groups everybody's still interested in. And it's sent out to destination address 224.0.0.1, and this is the all host address, this destination address. And it's sent out every 60 seconds. Every 60 seconds, R3, since it has the lower IP address, is going to send that general query out. And all of these hosts will receive it. And if these hosts are interested in a specific multicast group that they've requested before, they're going to send a membership report back. Now let's walk through that. Host 1 had already sent a membership report onto this broadcast segment to say that it's interested in receiving 224.7.7.7. R3 installed it, and R4 installed it into its IGMP group database, and it is now a multicast address that is capable of being forwarded onto this broadcast segment. Now, the 60-second timer interval arrives. R3 sends out its general query to 224.0.0.1. Host 1 sees that general query and says, you know what, if I still want to receive this 224.7.7.7, I need to send a membership report to 224.7.7.7 back to R3. Not specifically to R3, but back to this broadcast segment so that R3 can still maintain that it is an active group. Now let's hypothesize here for a second. What if there were 100 hosts on this broadcast network, on this segment here, the 100.0 network? And what if all of them were listening to 224.7.7.7, right? What if all of them were listening to that? And the 60-second timer came up, and R3 sent out that 224.0.0.1 general query to all the hosts on this broadcast network. Wouldn't it be a nightmare if all of them responded with a membership report? Can you imagine the flooding that would happen every 60 seconds? It's not optimal to do that. So there's a concept of a query response timer. And it's a configurable timer, and the timer is set to 10 seconds by default. And to go through it, we'll make believe that host 2 had also requested through a membership report to listen to 224.7.7.7. So timer comes up, 60 seconds, R3 sends out that general query onto this broadcast segment. Host 1 sees that general query, host 2 sees that general query. You know what, they still want to listen to 224.7.7.7. So they're going to pick a time between 0 and 10, randomly, 0 and 10, as a kind of timer for sending out that membership report. So, for instance, let's say host 1 got a random timer of 3 seconds and host 2 got a random timer of 8 seconds. Well, obviously, host 1's timer is going to expire before host 2, and host 1 is going to send out the membership report with destination 224.7.7.7, specifying group address 224.7.7.7 before host 2 sends it out, because the timer for host 2 is higher. Host 2 is going to see that membership report, and since it already sees that somebody else answered the general query for host 2 is not going to send out the membership report. Well, isn't that interesting? On this particular, in this particular situation, only one membership report is sent back to the querying router to maintain this group address as active on this network. Now, you would think in a perfect world that with 100 hosts, only one membership report would be sent back if all 100 hosts were listening to the same group address. Well, not necessarily. If it were a 10-second timer, you might want to increase this timer so that you get a more randomized interval, right? So with 100 hosts, right, with a 10-second interval, it's potential that 10 hosts, right, 10 times 10 is 100, 10 hosts would send a membership report at the same time back to the querying router. Now, you might want to raise this. You'd have to play with it. So the more hosts you have, the higher this query response timer you want to have, so that you don't have a ton of membership reports being sent back to the querying router. So that is probably the most difficult concept about this. Now let's get into the concept of the leave. So we're maintaining what groups are still active on this broadcast segment. Now, what happens when host 1 wants to leave and doesn't want to listen to 224.7.7.7? Let me clear out the whiteboard here for a second. So we're going to go into the leave process. Oops. Now, again, both host 1 and host 2 had sent a membership report saying that they are interested in listening to 224.7.7.7. And R3, the querying router, and R4 have this group address installed into their IGMP database. Now, host 1 closes their VLC media player and sends a leave, what's called a IGMP leave, out to the broadcast segment that we have here. And the destination address for this leave will be 224.0.0.2, which is the all routers address. Within this leave is the group address specified, 224.7.7.7, right? Now, R3's responsibility as the querying router is to make sure that host 1 was the only host out there that was receiving this multicast group address. And how this works in version 2 is R3 sends out a group specific query. And the group specific query is only going to specify 224.7.7.7. You know, in the general query we said any multicast group, could be anything. Let me know what's out there. Let me know what you hosts need. Well, the group specific query will have a destination address of 224.7.7.7, right? And specify the group address of 224.7.7.7. And once host 2 receives this, it will have, instead of 10 seconds, it will have 1 second. This is a 1 second timer, query response time. QRT, query response time. 1 second query response time. Host 2 has 1 second to respond. But the question is what is the dead interval? So if host 2 doesn't respond, if nobody else is listening to 224.7.7.7, what is the dead time? Well, it's times 2. So 2 of these group-specific queries is what it takes for this group to time out and not be forwarded on to this segment. Now, since host 2 has 1 second, it'll actually construct a membership report within 1 second and send it back to the querying router with destination address 224.7.7.7, specifying group 224.7.7.7. The querying router receives this membership report very quickly and doesn't time out that group address. Now this was a significant improvement over V1. V1 did not have this concept at all. So on V1, the timer was 60 seconds for the query, right? And it took 3 times. So you potentially had 3 minutes where this group address was being forwarded onto this broadcast segment before it times out. This was a significant improvement. Now we can get it within a few seconds and that group can time out. Alright, that's pretty much the concepts of IGMP. Let's go ahead and move over to GNS and do some actual capturing of traffic. Since I know that R3 has the lowest IP address, I know that it's going to be the querying router. So it's good to capture on its interface to see all of them, everything.